Hi, you guys. Welcome to the first part of Mr. Lay's video tutorials. This is for you if you are trying to understand how to solve for equations. So I got a problem up here and we're going to walk through it together. So let's just take a look at this one. So we got our first problem right here. It says 3x plus 7 equals negative x plus 1. We're going to start first with that. So let me write that on the side. So I'm going to write 3x. So I'm going to write letter A. We're going to write 3x plus 7 equals negative x minus 1. All right, I got my problem. So now that I got my problem, let's get into the nitty gritty of how to do it. So one, we're trying to move towards learning how to do these solving linear equations without using the tiles. But if I had to do the tiles and I had to create them, you know that there would be 3x tiles on one side, there would be 7 1 tiles, and then there would be a negative x tile, and there would be a minus 1 tile. So if I had to show that on a different picture, I'm going to change my color to blue. So let's pick this blue. So let's say we have an equation mat. So in the equation mat, there's the equal sign in the middle, and we have our little line in the middle that divides everything, right? And then you have 3x tiles that are positive, so they are blue for positive. Usually they're shaded in. And I got 7 ones. So I'm going to say 1, 2, 3, 4. And that's 6, 7, 8. But I'm going to erase one of them because, whoops, let me finish the picture. Actually, there we go. Nice. So I got 3 positives, basically, or 7 positives. So I'll shade them in like that. So all of these are all positive, okay? So if I had to show it visually, this is what it looks like. Now, this is what you do if you don't get it, okay? And then on the other hand, we got a negative x, so I'm going to do all of that in red. So I got a negative x, so negative x, and I got a negative 1 as well. Okay, so we got, let me shade the other one in red. Okay, now what is, oh, that's a little too dark. Let me find a different one. All right, maybe I just need to switch the color on top. We'll put negative x inside. Okay, so everyone knows it's negative x. So now we have to think back to what we learned from the tile moves, right? So we always have 3 tile moves. So 3 tile moves. One, we had the flip the tiles, right? We had 2, we had remove or add balances. Or 3, we had remove 0 pairs. Right? So what's the goal of this problem? The goal of this problem is to get x by itself. Just one x. Not 3 x's, not 4 x's, not negative x, just one x by itself. So let me look at this problem right now. So I have 2 sides of the equation here. So I need to figure out one way to get all the x's on the same side first. So number 1, you always want to get the x's on the same side. So how can I get all the x's on the same side? I need to move this negative x to the other side. And I'm basically flipping. So if I flip that negative x, what does that negative x become? You said it, it's a positive x, right? So now if I get a positive x on the other side now, how many x's will I have in total? Instead of 3 x's, if I move that other one over. Yeah, I should have 4 x's, right? So what's going to happen is basically we just made a 0 pair, and now it's gone. And we just added that x to the other side. We flipped it over. Sorry, that's not a 4, that's an x. So the total, if I had to add this all together, is now I'm going to have 4x plus 7 equals -1. So now I can erase this x, it's gone now. And now that it's flipped, now I have a new positive x. Okay? Now let me ask you, are my x's by themselves yet? No, I still have the 7 over here that I need to change, right? Let's do the same thing again. Let's flip it to the other side. So I'm going to flip this to the other side now. So flip. So think about it. So I'm flipping positive 7 to the other side. If I flip positive 7 to the other side, or I'm getting rid of it maybe, then that means if I had to erase this, it should now become negative. So this is gone. And now I have a brand new group of 7 negatives. And then I'm going to highlight those with pink, just to highlight that. And this one's pink too. So now how many negatives do I have now? So 1, 2, 3, 4, 5, 6, 7, 8. Now I have 8 negatives. So that means if I had to show you what it did in algebraically, I remove these 7 over here, and I remove 7 over here as well. It basically added -7 to both sides. So now what do we have? Well, I have a 0 pair here. And now I'm going to get 4x. Be careful. Look at your picture. So if I take away 7 from -1, which is the same as adding, if I owed somebody $1, then I borrowed 7 more, I would owe them 8. So it's -8. Okay. So now that I got rid of all of that, I still need to figure out how much is each x. I only want one x only. So think of it like, let's say we have 4 people here. So this is 4 people. And they all owe together $8. How would you figure out how much each of them owe? And that answer would be simple, because you would say, oh, then you should just divide by how much money you have by how many people. And notice that this number is always, you see how the 4 and the 4 at the top and the bottom are the same? And they're equal to x. They're next to x multiplying it. We're trying to get rid of the 4 next to the x because we're trying to get x by itself. So now I'm going to divide by 4 on both sides. It's basically, if I had to show you visually what we're doing, it's like I'm saying, hey, this x right here is going to take 2 of these negatives. And this x right here is going to take away 2 of those negatives. Let me clean that up a little bit so you guys can see a little more of it. So here, gotta erase that. So this x gets 2 of these negatives. Does that make sense? And that's your final answer, basically. Then you get x, because 4 divided by 4 is a giant 1. So it's 1x. And then 8 divided by 4, I know 8 divided by 4 is 2. But there's a negative sign here, and it's -2. That's my answer, and then that's how it matches with how each x in this picture right here gets -2. Okay? So that's how you solve a linear equation.